Hello friends, so today's topic is transformers. So what is a transformer? Now if we look at the basic definition of a transformer, then a transformer is a static device that transfers AC electrical power from one circuit to the other at the same frequency where the voltage level is usually changed. Transformer is considered to be the backbone of power system. It has no moving parts. Now let us take a look on the power supply system. For generation, transmission and distribution of electric power, AC system is adopted instead of DC system because voltage level can be changed comfortably by using a transformer. For economic reasons, high voltage are required for long distance transmission because with increase in voltage the current decreases, leads to very less IR square power loss, whereas for safety reasons low voltage are required for utilization. Now on, we take a look on the major applications of transformer. To change the level of voltage and correct in electric power systems, it is widely used in circuit of various home appliances, example adapter, refrigerator, stabilizer, air conditioning, etc. Now let us take a look on the working principle of a transformer. The basic principle of a transformer is electromagnetic induction. A single-phase transformer consists of two windings placed over a laminated silicon steel core. The winding have less number of turns is called low voltage winding, and winding having more number of turns is called high voltage winding. A winding to which AC supply is connected is called primary winding, and the other one is called secondary winding to which load is connected. Due to AC current I1 in the primary winding, a changing magnetic flux is produced in the magnetic core, and that alternating magnetic flux induces I2 current in the secondary coil with EMF E2. The magnitude of induced EMF in a coil depends upon the rate of change of flux linkages, i.e. E is proportional to N. Since the rate of change of flux for both the winding is the same, the magnitude of induced EMF in primary and secondary will depend upon their number of turns. Primary induced EMF E1 is proportional to N1. Secondary induced EMF E2 is proportional to N2. When N2 is greater than N1, the transformer is called a step-up transformer. Increase output voltage. When N2 is lesser than N1, the transformer is called a step-down transformer, where decrease of output voltage is C. Turn ratio. The ratio of primary to secondary turn is called a turn ratio, i.e. turn ratio is equal to N1 upon N2. Transformation ratio. The ratio of secondary voltage to primary voltage is called voltage transformation ratio of the transformer. It is represented by K. K is equal to E2 upon E1 is equal to N2 upon N1. Here take a note that a transformer cannot work on DC. Now we will take a look on major losses in a transformer. First is core iron losses, and the second one is copper losses. Now first take a look on core iron losses. Core iron losses are the losses that occur in a magnetic core. Now here it also consists a part which is called hysteresis losses. The work done by the magnetizing force against the internal friction of the molecules of the magnet produces heat. This energy, which is wasted in the form of heat due to hysteresis, is called hysteresis loss. Here take a note that the loss can be minimized by using silicon steel material for the construction of core. The second type of core iron losses are the eddy current losses. Induced EMF in the core sets up circulating current in random direction called eddy current. This current in return produces a loss called eddy current loss or I square R loss. Here take a note that this loss can be minimized by making the core of thin laminar sheets. The second type of loss in a transformer is the copper loss. The copper loss occur in both the primary and secondary windings due to the ohmic resistance. If I1, I2 are the primary and secondary currents and R1, R2 are the primary and secondary resistances respectively, then total copper losses is equal to I1 square R1 plus I2 square R2 is equal to I1 square REP is equal to I2 square RES. Now we will take a look on the efficiency of a transformer. The efficiency of a transformer is defined as the ratio of output to the input power, the two being measured in same units either in watts or in kilowatt. Here take a note that transformers are the most highly efficient electrical devices. Most of the transformers have full load efficiency between 95% to 98.5%. Dear friends, thank you for watching our video. Please subscribe the channel and share the video and stay connected for further updates.